Okay, it's all showing the picture. Mass of the ball is 450 gram, and then the ball of mass 140 gram falls vertically onto the bar such that it hits the bar at a distance of 50 cm from C, as shown in figure 3.1. Right? Variation with time of the velocity v of the ball during and after hitting is shown in figure 3.1. So the ball falls down, right? Hits the plank, then is compressed to a maximum. After that, it regain its shape, reach its maximum velocity, and then it goes up. Okay, we are asked to calculate the change in momentum. So they won't bother about the negative sign usually lah. Negative sign shows direction lah. That means it's going upwards lah. The change in momentum is upwards lah. Show that the force exerted by the ball, okay? Change in momentum, that force is just your change in momentum over time, right? This is the time, which is 0.04. Okay. Anything not clear? Yep. Anything not clear?
Why do you use 0.04?
That time there, from here to here, that time there.
Oh, okay.
Any other question?
Oh,
Okay, let's carry on. You should be able to draw the forces acting on the plank for a time that the ball is in contact with the bar. Use your data from figure 3.1 and B part 2 to calculate the force exerted on the bar by support A. Right? Support A is pushing down. That's why it is called X. Support B, this whole plank is pushing down, so this force is pushing up. We call it F. And then at the center of gravity, there's your weight, 450 gram. We change it to, right? This is gravity, acceleration due to gravity, not gram. And then this is where we just calculated, where the ball is in contact with the plank. So we want to calculate this one. So since these two are unknown, we can take moment about here. B, clockwise. Clockwise is this one, X. And this is 45, this is 25. So distance is 45 minus 25. And this is 0.25, 0.45 G, acceleration due to gravity, times 25 cm. Don't have to worry about changing the meter lah, because here we want to calculate X only. So if we use cm, all will be okay. You can change if you want to. And this one is in 33.3 Newton, 50 plus 25. And calculate out X is that. Right? So we are using the condition for equilibrium, no resultant moment, and no resultant force. Right? All the forces upward equals all the forces downwards. So F is the sum of all these forces. Okay. Anything here not clear?
no, no.
Okay. We will see whether we have time or not later on. Let's go to Okay, let's carry on with our density and pressure, page 166. Right. These are the syllabus. Haven't changed much. Even this is supposed to be 3.4 lah. This is the old syllabus lah. Okay, you won't worry about that yet. You are more interested in this one. And then definition of pressure. And then the pressure at the depth. Okay, try this one. Page 105. Number 1. What's the density of the liquid mixture? Can
Yeah.
find the total mass, find the total volume, and then total mass divided by total volume is the new density. Right? Because they don't interact chemically, they just separate as find a separate as a separate liquid. So let the mass be m. Right? Volume is mass over density. So liquid A mass m, liquid B mass m, total mass is 2m. Right? We are just using this formula. Volume is mass over density. The total density of one liquid is rho. Right? Calculate the volume, density of second liquid. Calculate the volume, add them up, total volume, and total mass divided by total volume. Okay? Total mass divided by total volume. Right? Total volume is just add these two together. That's why you get this one. New density is total mass over total volume. Right? It's total mass, it's total volume. Can
Yeah.
try this one. You're not worried lah that you because there are maybe 5,000 questions. They do repeat. It's okay. They're not worried that you have tried it out because you cannot remember the answer. Understand your problem? Right? Mass of atom, P, number of atom per unit volume, NP is N divided by volume, and number of atoms. So NP times N is total mass, V is total volume, density is total mass over total volume. Right? Total mass over total volume, total mass divided by volume. So it's NP. So same with then what is given? Density of P is greater than density of Q. Q check. Put in your this one, right? This is for Q, rho Q. Answer is 0. Can.
Yeah. Can.
Right, this one? (2013) November, variant 23. Can find
Yeah,
the equilibrium,
yeah. Very sorry.
change it to meter, right? By R square L, then definition of density, mass over volume. Mass is cross multiply density times volume. Density is given here. Volume, calculate already. So that's the answer. Can get 0.49 Newton.
Yes.
Okay, let's go to pressure. Right? T is constant speed. Submarine descent means going down vertically at constant speed. Three forces acting on the submarine are viscous drag, upthrust, and weight. Which relationship between the magnitude is correct? Draw a picture or picture in your mind. There's the motion, there's the weight, there's the drag, there's the upthrust. A constant speed means they are in equilibrium. Weight downwards, balanced by drag and upthrust. Descent means going down. Drag or friction oppose motion. That's a motion. The drag of opposite. Yeah, that's the equation. That means weight is greater than drag. Weight is greater than upthrust.
Uh,
This one, this is the mercury level up to here. Right, you want to find the air pressure in the lower limb here. See the pressure here at this level. What's the pressure inside this lower limb? Right? P is H rho G. Answer is C. Right? H rho G. H is y2 minus y1 and rho G. Then plus this pressure. What's this our reference level? Answer C. Can
yeah.
take this level. This is our reference level. So this air pressure is balanced by that height of mercury and that pressure there. So we add these two together. Y2 minus Y1 is the H rho, H rho G rho. Okay. And the pressure inside there is P. Right? This P and this P are different. Don't get confused. It's just to show you how we calculate the pressure of this mercury, length of mercury. Can
Yep.
height H of mercury barometer is recorded. The barometer is set up in another planet where the atmospheric pressure is half that of the Earth. Gravitational field strength is double that of the Earth. What's the height recorded? Right? It's recorded on Earth. So on Earth, P is h rho g. On the other planet, you are told the pressure is half. Right? The height is what you want to find. Then density the same. You are using mercury. Then this is 2g. Acceleration due to gravity is twice. Right? Double that of the Earth. So simplify that, take the half across, multiply again. For rho gx, these two are the same. Okay or not? G and rho can cancel off. So x is a quarter h rho.
Yo, what 2G?
Okay?
Oh, gravitational.
On the other planet is double that of the Earth. Gravitational field strength. So
Then
we
pressure. Pressure also double.
pressure is half. The most pressure.
Oh, it says, oh yeah, okay. Okay, yeah.
Yep.
Cool.
Go to formula and work it out. Right? Compare with the equation of straight line. So the gradient is rho g. You find the gradient, then you can find the density. Right? Gradient is I take the largest triangle, 3000 divided by 0.4. Then rho is 7500 here, divided by g, 9.81. Okay. Okay now.
Yeah.
An object is immersed in a liquid in a tank, experience an upthrust. What physical reason for this upthrust?
Let's see.
Okay, good. See, which equation or principle of physics is used in the derivation of the formula H rho g? Yep. What's the answer? Pressure is weight over cross-sectional area. Right? Mass replaced by density times volume. volume is A times H. Okay now,
Yeah, can.
the answer is A. What's the answer for this one? What's the answer?
B.
Sorry?
Boy.
No. Force of R is greater, pressure at R is greater than pressure at P. Force or pressure. S and Q is the same. Okay? A.
So upthrust is more than the weight. Upthrust and drag.
Sphere experience upthrust. So this force is greater than that force. That's why there's an upthrust.
More than the weight.
That one we cannot say anything. Depend on what
Oh,
is
okay.
the what is this object, whether it's wood or whether it is iron. So we don't know. We only know that the force R is greater than the force P. Right? These are forces acting on the sphere, not the weight of the sphere. These are forces acting on the sphere. That means it's by the liquid due to the pressure of water. Okay. Yep. What is not clear?
And
Which of the following expression is equal to the upthrust on the block? This is what you just asked. You want upthrust only?
D. Donkey.
Huh?
Donkey.
No. C.
Oh.
Donkey is the resultant force.
Oh, okay.
Okay. What causes upthrust on a submarine?
B. Wait.
Yeah,
Uh,
donkey lor. D.
yeah.
This one you should know lah.
Q.
Right? Take the reference level where the two liquids separate lor. Call that A, and then the same level, call that B lor. Right? H rho G, pressure at A equals pressure at B. Right? Is 2x, and density of P times G. This one is density of X. This one is X, and density of Q times G. Then cross multiply lor. Take rho Q out. X and X cancel out, then get the answer lor. Okay. Anything not clear?
Okay.
Wait, how come no structure question? How come there's no structure question? Define pressure. This is our last question lah. Define pressure.
Uh, Ratio of, I don't know, cross-sectional area
Force per unit
or
area lor.
force per unit. Yeah, force per unit.
Take
Okay.
the unit of pressure in base unit. Right? Go to the formula lor.
This unit, kg. Okay.
Right? If not, use this formula lor. Use this formula to derive it lor. Right? Density is unit there. G H rho G has a base unit of right? Okay.
Yep.
State how it is known that pressure at the base of a column of water is the same as the pressure at the base of a column of oil. This is a
Same
question.
depth.
This is a question. Column of water, column of oil, the base there. Okay.
Yeah.
Pressure is the same at the surface of Mercury because it has the same horizontal level. Column of water, density given 50 cm. Column of oil is 75 cm. Calculate density, explain the working. H rho G is the same for both. Right? Convert it. This is the question. Right? Convert this 53 to meter. Convert that 71 to 71 cm to meter. Right? Use this formula. And calculate out. Okay, now anything not clear?
Okay.
We still got 8 minutes, so might as well do something about it. Right? You make full use of it. You got 8 minutes. Right? State what is meant by center of gravity. This is under forces.
The center of image
A point at
gravitational
which the
force
weight of a
acts.
body appears to act. A uniform rectangular sheet of card of weight W is suspended from the wooden rod. That's a wooden rod. The card is held to one side as shown in figure 3.1. On figure 3.1, mark and label the letter C, the position of center of gravity. Right? Just draw a line there where the diagonal cross, that's the center of gravity.
The
And mark the weight. That's the weight. Okay,
yeah.
the card in B is released. The card swings on the rod and eventually come to rest. Least the two forces other than weight and air resistance that act on the card during the time when it is swinging. State where the forces act. You got normal reaction or friction. The force act on the rod. By reference to completed diagram 3.1, state the position at which the card comes to rest. Explain why the card comes to rest in this position. Come to rest with the line of action of the weight acting through the rod C vertically below the rod, so that the weight does not have a moment about the pivot or rod. Can you understand?
What's the rest of the action? It means it comes to rest when there's no pivot.
This one is not in equilibrium. So this one will swing until the center of gravity is just below it, below this one. And then the weight is just directly there.
Yeah.
Okay, since we still got a bit of time, might as well use it. Make full use of it. Okay, 24. Same thing. Define moment of force.
Uh, moment.
Product of force and perpendicular distance to the pivot. All this must be in your head. All these are scoring point. Right? Student is being weighed. The student or weight W stands. Right? It's shown on the diagram. All of it. I'll let you read yourself. Okay, can I change?
Uh, sure.
State two conditions necessary for the plank to be in equilibrium.
No resultant moment. No resultant force.
Or resultant moment. Resultant moment is 0. Resultant force is 0. Or sum of clockwise moment equals to sum of anti-clockwise moment. Determine the weight of the student. Right? There's a force acting at P. Right? Upwards there. So we don't know that. So we take moment about P. Then we don't have to worry about the force acting at the pivot there. Then sum of clockwise moment equals to sum of anti-clockwise moment. So anti-clockwise is W times 0.5 minus 0.3, 0.2. And this 80 is 1. So this one is 1 minus 0.3. Sorry, you want P, that distance there. So it's 80 times 1 minus 0.5 is 0.5. And this one is 70. 70. Right? From that distance is 0.5. Right? That distance is 0.5 plus that one is 0.8 is 1.3. Can. That distance is 1 to the end there. 1 minus 0.2 is 0.8. Yep. Can or not? Not clear?
Yeah.
You don't have much time already unless you got any question you want to ask, any clarification. If not,
I don't have questions, but can you send me, do you have like a worksheet or forces?
say again.
Worksheet for forces.
You want the note
Worksheet.
worksheet I give you already
Just like the conservation of
past
momentum.
year